Hello, and welcome to another Learning Together session sponsored by the Brosis Foundation. It is truly a privilege for us to share in your journey and to provide you opportunities to increase your knowledge in math and in English. Last time we were together, we introduced the graphing of parabolas and also started to analyze the parabolas based on the equation. Today, I'm going to review what we did the last time and then add some more things to it, okay? For example, we dealt with the standard form. Today, we'd like to also add to it the vertex form, okay? So let's go for a quick review. What is a parabola? A parabola is really a graph of a quadratic equation. And the general form of a quadratic equation is y equal to ax squared plus bx plus c. That is the general form of a quadratic equation. And what we discovered is that if you graph this, you will get a curve, you'll get a u that opens either upwards or downwards. And there are different ways to tell from the equation whether the graph is going to open up or open downwards. We'll get there gradually. Just to give you a quick review, we said that the parent function, or say the basic quadratic equation, is y equal to x squared. That's the simplest, the basic. And we said the graph of this looks something like this. Here's your x-axis, here is your y-axis. And the graph of y equal to x squared is something of this format. It looks like that. And then part of our discussion, we look what happens to the graph, how it shifts, whether to the left or to the right, whether up or down, based on how the equation is modified. For example, if we had y equal to x squared plus 4, we discovered that what will happen from here is that every y value would go up by 4 units. Whatever the y value was before, just add 4 to it. Just keep adding 4. So your graph would be shifted vertically. Your graph, instead of starting at the origin, which is 0, 0, it would start at 4. And it would be the same shape as this. So it would look like that, opening upward. But instead of starting here at 0, 0, at the origin, it starts on the y-axis where y is equal to 4. That's because of this positive 4. Conversely, instead of having a positive 4, if we had, say, for example, a negative number, like suppose we had, say, y equal to x squared minus 2. So then what that will do is that will cause the graph, instead of going up 4 units, it would go down and start at negative 2. And then it would open upwards. So this would be the graph of y equal to x squared minus 2. And this is the graph of y equal to x squared plus 4. So what did we notice? If there's a number next to your quadratic term, this is a quadratic term, if you add a constant, it shifts your graph vertically. So it's a vertical shift or vertical translation. Translate is to slide, to just move it consistently in one direction, like a vector, okay? Similarly, if the change was not here, but the change was with the x, it would cause a difference. So let's see what the difference is. We discovered that if instead of y equal to x squared, if you had y equal to x plus 2 squared, so now the x value is impacted. You're adding 2 to the x value. We actually discovered that your graph would shift. This is where your vertex, we'll talk about the vertex later. This is where it was. Now it's going to actually, the positive 2 causes it to shift 2 to the left. You would have thought to be 2 to the right. But it's actually 2 to the left, and the graph has the same shape as before, except that instead of starting at the origin, which is here, the positive 2 causes it to shift to the left 2 units. And if it was y equal to x squared minus 4, sorry, not x squared minus 4, but x minus 4 squared, instead of going to the left, it would go to the right. So starting here, it will now, this will be where it is, and you'll end up with the graph shifting to the right 4 units. With a minus, it goes to the right. With a plus, it goes to the left. Very important difference. So what did we find? We find that if the number is within the quadratic term, it causes a horizontal shift. Positive goes to the left, negative goes to the right. If the addition is away from the quadratic term, then it creates a vertical shift. If it's positive, it goes up. If it is negative, it goes down. Great. Okay, so it goes to say then that if you had a graph that looks like this, y equal to x plus 3 squared minus 2, then the positive 3 here means that you shift 3 units to the left. The negative 2 means that you go down 2 units. So if this is your y-axis and this is your x-axis, instead of starting at the origin, you're going to go 3 here, negative 3, and 2 down. And this is where your pointed, this is where your vertex or turning point is going to be. So your graph is going to end up looking something like that. So look what happens. This creates 2 different shifts, 1 horizontal, 1 vertical. 3 to the left, 2 down. 3 to the left, 2 down. Okay? So that's the translation that occurs when we modify the parent function. Okay? What else can happen? Well, suppose instead of having y equal to x squared, we end up with y equal to, say, 2x squared. Notice, whatever the x value, whatever the value was for y, this 2 means that that number is going to double. For example, when x was 1, y is 1. Now when x is 1, y is going to be 2. When x was 2, y was 4. Now when x is 2, y is 8. When x is 3, y is 9. When x is 3, y is 18. So your graph is going to get narrow. So what's going to happen is, here is your graph. If this number is bigger than 1, it's bigger than 1, it causes your graph to become narrow. If it is less than 1, like for example, a half, a quarter, 1/3, 1/5, 1/4, 2/3, whatever it is going to cause your graph to open up more. It's going to open up more. For example, suppose it was y equal to 1/2 x squared. When x is 4, then y is going to be 16. 4 squared is 16. When x is 4, y is going to be 16 times 1/2 gives you 8. So instead of y being at 16, it's going to come down to 8. So it's going to be, the graph is going to open up wider. Okay? And then the last very important concept I need to cover with you is what happens if your A is negative or if it is positive. If you have y equal to ax squared, if A is negative, that is, it's less than 0, okay, it's a negative, it means that your graph opens downwards. So your graph is going to be like this, opens downwards. If your graph is, if your A, your lead coefficient is positive, greater than 0, your graph is going to open upwards. And the only way I can encourage you to remember it is think of it, negative is down, negative. So it opens down. It starts high, but it goes down. Positive goes up. Positive goes up. When your bank account goes up, that's a positive sign. Okay? So therefore, in that case, we say that it opens upwards, starts from a low, but then it goes up. And that's when A, the lead coefficient, is positive. Okay? There are a couple of items I would like to define when approaching the graphing or the sketching of the graph of a parabola. Okay, here we go. Okay. Let's imagine if your parabola was like that. There is what is known as the turning point. It's called the vertex. V-E-R-T-E-X. That's the vertex of your parabola. The vertex, at the vertex, the x value at the vertex happens to be the middle of your parabola. It's symmetrical about the x value here. It's very symmetrical. So if your vertex was, say, the point A, comma B, then x equal to A would be the equation of the axis of symmetry. It's called the axis of symmetry. Or it's just the center of your parabola. It's the middle of your parabola. It's the mirror line, runs smack through the middle. Okay? What are some of the other key things to keep in mind? This will be called the Y-intercept. That's where your graph cuts the y-axis. This and this, these two are called the X-Intercepts. So what are the key things we need to recognize? We need to recognize the vertex. We need to recognize the axis of symmetry. We need to recognize the Y-intercept. We need to recognize the X-intercepts. Okay? Quite a few things. But if you know these things, you're going to be able to graph the equation of a parabola. You can graph any parabola that you're given. So let's look at a couple of examples now then. Or maybe I should, before I do that, how do we find the vertex? I'm glad you asked. For the vertex, the x value at the vertex is equal to minus the negative of b over 2 times a. So it's the negative of the coefficient of the linear term, the x term, divided by 2 times the coefficient of the quadratic term, the term with x squared. It's minus b over 2a. So that's going to give you the x value at the vertex. Now watch this. Once you know the x value at the vertex, you plug it into the equation to find the corresponding y value at the vertex, because the vertex is a point, and points have both the x coordinate as well as the y coordinate. So you find the x by doing minus b over 2a. You find the y by plugging in the x value into the equation. Then we also know that the axis of symmetry is also x equal to minus b over 2a. That is the axis, that's the equation of the axis of symmetry. One more thing to keep in mind, how do you find the x-intercept? You find the x-intercept because everywhere on the x-axis, this is the x-axis, and this is the y-axis. Everywhere on the x-axis, y is 0. So to find the x-intercept, you change the value of y, put it to 0, and then solve the equation to get the x values. And whatever values you get for x will tell you where the graph cuts the x-axis. The y-intercept, everywhere on the y-axis, x has a value of 0. So to find the y-intercept, you plug in x as 0, and therefore y is going to be this number here, c. That will always be your y-intercept. Okay? One more thing to keep in mind, every point has a corresponding point on the other side of the axis of symmetry. So if you have a point here, there's going to be a point over here. That's equal distance from the axis of symmetry. Same distance on the left and on the right. Those are corresponding points. Okay? So now that we have laid the foundation, let's go to work. Let's look at some examples. Okay, so let's look at a couple examples and let's see if we could get some things taken care of. For example, y equal to x squared minus 6x plus 5. X squared minus 6x plus 5. Okay, so let's go for the vertex. First of all, we notice that our A is 1 and it's positive. So we know that our graph is going to open up. Positive is up. Okay, negative is down. Okay, so we know the graph is going to open upwards. So let's go for the vertex. X is equal to minus b, which is minus negative 6 over 2 times a, which is 1. And that's going to be equal to 6 over 2 gives you 3. So we know the x value at the vertex is 3. Now we need to find the y value at the vertex. How do we get it? We plug in for x in this equation. We end up with y equal to 3 squared minus 6 times 3 plus 5. So it's equal to 8 minus 18 equals to negative 10. So it's 3 squared is 9. Oh, 3 squared is not 8. Ha, ha, ha. 3 squared is 9 plus 5. I don't know what just went down. So 9 plus 5 is 14. Take away 18 leaves negative 4. That's better. So our vertex is the point 3, negative 4. Okay, let's get our x-intercepts. Okay, for the x-intercept, we know that y is going to be 0. So x squared minus 6x plus 5 equal to 0. And we have discussed how to solve quadratic equations. As a matter of fact, we discussed 3 methods. 1, factoring. 2, quadratic formula. 3, completing the square root. All of that is done on a different session, learning together session. So search the videos, Desmond Dunkley. You will see it on the Brosis website and you'll get it. So this, when factorized, gives you x minus 3, x minus 5, and x minus 1. And by using the zero product property, we discovered that x is equal to 5 or x is equal to 1. So the two intercepts are 5, 0 and 1, 0. Those are the two x-intercepts. What is the y-intercept? The y-intercept is obtained when x is 0, so we end up with y equal to 5. So now we have quite a bit of information. We can actually sketch the graph. So we have 3, negative 4. So we have, most of it is over on the right, so I don't need to be equal. I can do something like this. So 3 and negative 4. This is your vertex. That's your vertex. Where are the intercepts? 1 and 5. So if that is 3, this will be 2, this will be 1. And then this will be 4, this will be 5. This is 1, this is 0. And then we have the y-intercept, of course, is 0, 5. So this is 4. So 5 is about here. Okay, so this is your axis of symmetry. And we know that our graph is going to come something like this. We're going to have a point over here. This is 1, okay. So 0, 3. So then we need to go over to 6 and 5. Okay, let's go. Okay, so this is your graph of y equal to x squared minus 6x plus 5. Okay, so that's one. Let's do another. So this time I'm going to try and do one that opens upward. So I need my glasses for the fine print. Here's one that goes like this. Okay, so this is number 2. Y is equal to negative x squared plus 2x plus 3. So here we go. So the vertex. For the vertex, we know x is equal to minus b, which is 2, over 2 times a, which is negative 1. A is negative 1, 2 times negative 1, and negative 2 on top. So we get x equal to 1. Okay? When x is 1, y is going to be equal to negative 1 squared plus 2 times 1 plus 3. And that's going to be equal to negative 1 plus 2 plus 3. So that gives me 4. So therefore, our vertex is the point 1, 4. 1, comma 4. That's our vertex. What is the y-intercept? The y-intercept is going to be, when x is 0, the y-intercept will have to be 3. What about the x-intercept? X-intercept, if it exists, or if they exist, we'll end up with 0 equal to, for the x-intercepts, y must be 0. So 0 equal to negative x squared plus 2x plus 3. To solve this, I'm going to bring everything over to this side. We have x squared minus 2x minus 3 equal to 0. And now I can factorize. I see I have x minus 3 and x plus 1. And then from here, I can see that my x-intercepts are x equal to 3 or x equal to negative 1. So we know that our intercepts are at negative 1 and positive 3, and we know that our vertex is 1, 4, where this x equal to 1 is the axis of symmetry. Okay? So let's see what we have here. So our vertex is 1, 4, and it opens, because it's negative, it opens down. So let's go. So 1, 2, 3, 4. 1, 2, 3, 4. And then going up, we have 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Okay, and of course, this is 0. Remember, this is just a sketch. Okay, so our vertex is 1, 4. That's our V. So the graph is going to open downwards. Okay, our intercepts are 3 and negative 1. Negative 1, positive 3. If you notice, this is our mirror line. Okay, that's central. And then our y-intercept is positive 3. So positive 3 is here. And then, of course, this is 1 to the left. So 1 to the right goes here. Okay, good. And now we need to draw our graph that goes somewhat like this. Okay, so this is a graph opening downwards. So now you know how to graph using your standard form. What we need to cover now is another form for your parabola. It's called the vertex form. So let's go. So we need to be able to convert from the general form to the vertex form. And the best way to do this is first to define what the vertex form looks like. So general form is y equal to ax squared plus bx plus c. You can also write it as f of x equal to ax squared plus bx plus c. And then the vertex form is y equal to a times x minus h squared plus k, where vertex is h. This is very important, very, very important. Let me take a sip of water while you take a look at this. With the standard form, with the general form, you have to calculate the vertex. With the vertex form, you can actually just look at it and tell the vertex. So whenever you get the vertex form and they ask you, what is the vertex? What is the axis of symmetry? Boom, boom, boom. They're just right, they just read them off. Whereas with the general form, you would have to actually do some processing to obtain those answers. Okay? So the vertex form says y is equal to your lead coefficient is here outside the parentheses, and it's always x minus the h value, which is your x value at the vertex. H is the x value at the vertex. Okay? Squared, that's how you get the quadratic, squared plus k. So it's always plus k, where k is the y value at the vertex. Okay? So let's go to work. Let's see if we can make some things happen here. Okay? And then we'll be able to pull it all together. It's going to get a little tricky, but stay with me. Okay. Okay. So the first thing to do is to be able to pick out the vertex and the axis of symmetry. So find the vertex and axis of symmetry for each of the following. Okay, the first one. Negative y equal to negative x plus 3 squared minus 1. Let's do that as the first one. Watch carefully. It is supposed to be y equal to a times x minus h squared plus k. That is a vertex form. So if you're supposed to have minus h, but now we end up with a plus 3. So how can you end up with a plus 3 if it is supposed to be minus h? Then it means that h has to be negative 3. So the vertex and then it's supposed to be plus k. But this is a negative 1, so k has to be negative 1. So that would be a vertex. What is the axis of symmetry? The axis of symmetry is always the x value at the vertex. So the axis of symmetry is x equal negative 3. Let's try another one. Okay. Another one we'll use is, okay. Okay, here we go. Minus y plus 2 minus y plus 2 equal to x minus 2 squared. From this, we would like to find the vertex and the axis of symmetry. So in order for us to do that, we need to get this to look like that. We need to rework it. Rework this so that it looks, rework this, sorry, so that it looks like that. So we need to get y by itself, positive y by itself. So how do we do that? Well, first, let's get rid of the negative sign. Let's get rid of the parentheses. So we end up with negative y minus 2 equal to x minus 2 squared. Then what are we going to do now? Get rid of the negative 2, so we add 2 to both sides. So we end up with negative y equal to x minus 2 squared plus 2. We add 2 to get it over to that side. And now one last step here, y is equal to negative x minus 2 squared minus 2. So now we have it looking like this, where a is negative 1, h would have to be 2, and k would have to be negative 2. So your vertex, it's going to be 2, negative 2. And the axis of symmetry is x equal to 2. Okay? Let's try and do one that is more complicated, maybe. Let's see if there's one that is a little bit more complicated. Okay. Let me make some space on the board, and then we can do some more examples. Okay, here we go. Okay, so here's another one. This one says f of x, this is number 3. F of x is equal to negative a quarter x Okay. So what is the format? Y equal to a times x minus h squared plus k. That is the format. So what is our h? So the vertex is going to be equal to 1. Your h is 1, comma, your k is 4. And of course, our axis of symmetry is x equal to 1. Number 4. Okay, this is the last one for this. So f of x equal to a quarter times x plus 4 squared plus 3. So the vertex will be equal to, again, we don't need to worry about the a, we just need to worry about the h and the k. So what's the format? It's x minus h. The fact that we have a positive sign here means that h must be a negative number. So what is it? So it's going to be negative 4, comma, plus k plus 3. So k is 3. And then of course, our axis of symmetry is x equal to negative 4. So now that we know how to pick out the vertex and the axis of symmetry, what we need to be able to do now is to be able to convert a standard form or a general form to the vertex form, and also vice versa. Okay, so we need to be able to convert from one to the other. I did cover that in a previous video, but because it's very important to this, I need to do it in this section again. Okay, so bear with me as we go into that now. So what is our goal? Our goal is to get y equal to a times x minus h squared. That's our goal, okay? So we're going to take a few questions that are in general form and then rework them so that they look like this. So it says, use the information provided to write the vertex form of each parabola. So we need to write the vertex Okay, so number 1. Okay, so the first one is y equal to x squared plus 16x plus 71. y equal to x squared plus 16x plus 71. Okay, there are different ways to explain this, but I'm going to use one way that makes it, what I think, less prone to error. What I'll do is I'll move this over here and then just focus on these two terms only. So now we have y minus 71 is equal to x squared plus 16x. All we did was just move the constant over here, and that's temporary. It's just a temporary move, because eventually you want to have y by itself. Okay? Okay, good. Woo. So now this, how can I write this as something squared? It would have to be y minus 71 equal to x. You always take this number here and divide by 2. So this is 16 divided by 2, we end up with plus 8 squared. But if we did this, we would end up with x squared plus 16x plus 64. So this is going to create a 64, an extra 64 from this expression here. So in order for us to keep it equivalent to what it was before, I need to subtract 64 from this. Can I prove it? Let's go, x plus 8. X plus 8 times x plus 8 equal to x times x, x squared. X times 8, 8x. 8 times 8, 8x. 8 times 8, 64. Add these together, we end up with x squared plus 16x plus 64. So the parentheses is going to give you a trinomial. It's going to give you 3 terms, but what we had above was just a binomial, just x squared plus 16x. So to keep it equivalent, I had to subtract the 64, so that this will only end up in x squared plus 16x. And now I need to bring this back over here, and we'll be done. So by adding 71 to both sides, we end up with y equal to x plus 8 squared minus 64 plus 71. I just bring back the 71 over by adding. So therefore, the final answer is x equal to x plus 8 squared, and negative 64 plus 71 seems to be plus 7. From this, what is the vertex? Well, the vertex would have to be negative 8, comma 7. And of course, the not the X-Intercept, sorry, the Axis of Symmetry with x equal to negative 8. Now, let's go back to before we talked about the vertex form. Suppose I just looked at this and I asked you to find the vertex. Let's see if it would come out with the same answer. Keep your fingers crossed. Let's see. Okay, according to the formula that we learned, we say at the vertex, x is equal to minus b over 2a. So b is 16, so it has to be minus 16 over 2 times a. So it's 2 times, what is a? A is 1. Do you see that that's equal to negative 8? That's negative 8, right? So far, so good? Nice. And we said our method that we had was that we take the x value, plug it into the equation, and that is going to give you the y value. So y is equal to negative 8 squared plus 16 times -8 plus 71. Are we gonna get 7? Keep your fingers crossed. Let's go. So that's, this times this gives me 64. And let's put the 71 beside it, plus 71. And then this times this is gonna give me minus 8 6s 48, 8 1s 8 and 4, 12. So it's 128. So it's equal to 4 plus 1 is 5. 6 plus 7 is 13. So it's 135 minus 128. What is 135 minus 128? Isn't that 7? There it is. How cool is that? Pretty cool, right? Okay, so that's the first one. Let's try another one. It will get more complicated, so don't get bored. It's going to get a little bit more involved. Just hang on a little bit. Let's go for the second one. Remember, the rule in math is that if the math is correct, if the method is correct, you should end up with the same answer. So if the answers are different, then something is wrong somewhere. Okay, let's try another one, number 2. Okay, let's go for, okay, let's try this one. Y equal 2x squared plus 36x plus 170. These are some big numbers. And our job is to get this to look like that. Remember, your A is always your lead coefficient. So this 2 is going to be outside your parentheses. Keep that in mind. It has to be outside your parentheses. Okay. The method that I encouraged you to use was to take this and move it to the left temporarily. So we have y minus 170 equals to 2x squared plus 36x. So now we notice we could factor out a 2. So then we end up with y minus 170 equals to 2 times x squared plus 18x. And now we are in a position where we can start prepared to complete the square. Okay, so now we have y minus 170 is going to be equal to 2 times, what we said is that whatever number is here, we divide it by 2. So this is going to be x plus 9 squared. Okay, but watch this. X plus 9 times x plus 9 is going to give us x squared plus 18x plus 90 plus 81. And then when you multiply 2 times 81, we're going to get 162. But there's no 162 here. There's no 162, it's 0. So to make what is here equal to what is above, I need to subtract 162. Let's do that one more time. When I square this, watch this 2 that is outside. Watch the 2 that's outside. Okay, when I square this, I end up with x plus 9 times x plus 9. That's going to give me x squared plus 9x plus 9x plus 81. Give me x squared plus 18x plus 81. Okay, that's when I multiply these two. Then when I multiply it by 2, it's going to give me 2x squared plus 36x plus 2 times 81 gives me 162. But here there was no, notice the 2x squared is good, the 36x is good, but now we have a positive 162. So therefore, this is not equal to this. So in order to make it equal, I need to remove the 162. So that's why I subtract 162. And now I can bring this over and combine it with this, and my job is done. So y is equal to 2 times x plus 9 squared minus 162 plus 170. So y is equal to 2 times x plus 9 squared and minus 162 plus 170 gives me plus 8. What is the axis of symmetry? It's going to be, notice, x minus h. So then since this is a plus 9, then your h is going to be negative 9. Plus k, so k is going to be just 8. So the vertex, just by looking at the vertex form, I picked off the negative 9 and I picked off the 8. Again, you know the question I'm going to ask. Without doing all of this, would I get a vertex of negative 9, 8 from the original equation? Would we? Let's find out. Okay, so x is equal to minus b over 2a. B is 36, so minus b is negative 36. A is 2, so it's going to be 2 times 2. So we see that negative 36 divided by 4 gives me negative 9. There is a negative 9 for the x value. Keep your fingers crossed. Let's see if when we plug in negative 9 into that equation, if we get 8 for the y value. Let's go. Y is equal to 2 times negative 9 squared plus 36 times negative 9 plus 170. Negative 9 times negative 9 is 81. 81 times 2 is 162 plus 170 minus 9 times 6 is 54. 9 times 3 is 27 and 5, 32. Add these two together, we end up with 2. 7 and 6 is 13. 1 and 1, 2 and 1 is 3. So it's 332, take away 324. Guess what? 32 take away 24 is 8. Perfect. Perfect, perfect. So I just need to do one more question to seal the deal, but this time I'm going to move very fast, but just to confirm the process, okay? Okay, so looking at this here, we have, this is example 3. X squared minus 12x plus y plus 40. X squared minus 12x plus y plus 40 equal to 0. And that is the work that we have to do. Ready? Let's go. The y and the constant are together. So let's move these two over to the other side. So we have y plus 40 equals to negative x squared plus 12x. When this goes over here, it becomes negative. When this goes over here, it becomes positive. These two remain here. For now, the 40 is going to go over after we do the work. We'll take the 40 over to the other side. So let's go y plus 40 equal to, let's factor out a negative 1. Now we have x squared minus 12x. If you factor out a negative 1, then this becomes positive x squared. This becomes negative because look, negative 1 times x squared gives me negative x squared. Negative 1 times negative 12x gives me positive 12x. So now we know that our a is going to be negative 1. So now we can go, it's negative 1 times x, divide this by 2, I get negative 6 squared. Let's watch for the adjustment. Watch for the adjustment. When I square this, I get x squared minus 12x plus 36. When I multiply by negative 1, the plus 36 becomes minus 36. So therefore, I need to add 36 here to balance it out. Let's check. When I square this, I get x squared minus 12x plus 36. When I multiply by negative 1, I get negative x squared plus 12x minus 36. But negative x squared, 12x minus 36, there was no 36, there was no minus 36 here. Now we have a minus 36. So to get rid of this minus 36, I must add 36 to cancel this. Because this now introduced a negative 36, we add 36 to keep it balanced. And so now we can finish the job. We can bring this over and we're done. So now we have subtract 40 from both sides. We end up with y equal to negative 1 times x minus 6 squared plus 36 minus 40. We have a positive 40 here, so to read over to the other side, it becomes negative 40. So our final answer is negative 1 times x minus 6 plus 36 minus 40 gives me minus 4. So what is our vertex? The vertex is 6, negative 4. 6, negative 4. So are you going to ask me to check if it would have been correct if we did it just by what we had? I can do that, sure. So I'm going to need a space. So we keep this right here, 6, negative 4. And we're going to get it in the general form, and then we take care of it. So this is going to be y equal to, this goes over here, it's negative x squared. This goes over here, it's plus 12x. This goes over here, it's minus 40. Let me double check. We want the y to be by itself. So x squared goes over, from negative x squared. Negative 12x goes over, it becomes positive 12x. Positive 40 goes over, it becomes negative 40. So x is equal to minus b over 2a, so is equal to negative 12 over 2 times negative 1, 2a. So that's going to give me negative 12 divided by negative 2 is 6. There is a 6. You got the 6 right there. So now we're going to plug in 6 into this equation to get y. So y is equal to negative 6 squared plus 12 times 6 minus 40. So it's going to be equal to 6 squared is 36, so it's negative 36. 12 times 6 is 72. And then minus 40. Negative 36 minus 40 is negative 76 plus 72. Negative 76 plus 72, that equals to negative 4. And that is exactly what we had from the vertex form. So we have come to the end of our session today, Learning Together, sponsored by the Brosis Foundation. I do truly trust that you learned something or you are reminded of something that you knew before. I hope that this has been beneficial to you, and I encourage you to tell a friend. This is free. The purpose of this is to help those who need help. That's what it is. So the more people become aware of it, the more beneficial it will be, and the more satisfied we will be knowing that we are satisfying a need, or we are fulfilling a need. So, on behalf of the Brosis Foundation, this is Desmond Dunkley, thanking you for joining with us and spending this time today. Looking forward to you joining us for another Learning Together session sponsored by the Brosis Foundation. Enjoy the rest of your day.